Question 1 asks us to describe the transformation which maps triangle A onto triangle B. The first thing to look at in a question like this is the number of marks, because the number of marks will be equal to the number of bits of information which you need to give. It does state that it's a single transformation, so we are trying to think about, is it a translation, a reflection, a rotation, or an enlargement? A translation means that the shape has simply moved position but not changed size or changed orientation, and we can see that this shape has not just simply moved position. An enlargement means that it gets bigger or smaller, a rotation means that it is spun, and a reflection means that it's a mirror image. Hopefully you can see that this shape is a mirror image of itself, meaning that we know that the answer is going to be a reflection. That is the first mark. So you've now got 1 out of 2 marks. In order to get the second mark, we have to say which line the shape has been reflected in. To do that, take 2 corners, so looking at this one and this one, count the squares in between them and mark the halfway point. So 1, 2, 3, 4, there are 4 squares in between them, so the halfway point would be on this line. This then is our mirror line. You need to know the equations of general lines, as in horizontal lines, vertical lines, and some diagonals. A horizontal line is y equals, and a vertical line, which is what we have here, is x equals. So this line goes through -1 on the x-axis, meaning that this is x equals -1. So for 2 marks, reflection in x equals -1. The second part of this question asks us to translate triangle A by 3 minus 2. Remember, translate means that you simply move a shape, and this is called a vector. The top number tells us how many squares right or left we move. A positive top number means we move to the right, and a negative top number would mean that we move to the left. The bottom number tells us whether we go up or down. Positive means we go up, negative means we go down. The best way to go about one of these questions is to move the shape corner by corner. So with shape A, starting with this corner here, we need to go 3 squares to the right, 1, 2, 3, and then 2 squares down, 1, 2. From this corner, we have to go 3 squares to the right and 2 squares down. And then for this corner, 3 squares to the right and 2 squares down. That now gives us the outline of our shape, and we simply connect it up. Always make sure to label the triangle as they have asked you. The final part of the question asks us to rotate triangle A 90 degrees clockwise about the point 02 and to label this new triangle D. The first thing that we do is mark the centre of rotation, which was given in the question, so point 02. Now I'm going to zoom in on this question to make it a bit clearer. We are rotating 90 degrees clockwise. When you're doing a question like this, you will have tracing paper. And what you're going to do is trace around your starting shape on your tracing paper. Label the top of your tracing paper, maybe with a little arrow or something, just to sort of show the top bit of the tracing paper. And then you're going to begin to turn the tracing paper whilst keeping your finger or your pen on the centre of rotation. So holding it firm in this place and spinning the page about that point. So as we begin to move our shape through 90 degrees, using the arrow to help to show us once we have reached 90 degrees, we see that it ends up at that point. So as you can see, I have done a quarter turn where my arrow began pointing towards the north and is now pointing directly east. So that was a turn of 90 degrees in a clockwise direction. I can now see the new coordinates of my shape. So this point has moved to a coordinate of 1, 0. This point has moved to a coordinate of 3, 1. And finally this point has moved to a coordinate of 6, -2. This question is an enlargement question, and in an enlargement question you need to be given the scale factor. That basically means how many times bigger to draw the shape. So the current shape has a side of 2 squares going vertically. Because we're doing scale factor 3, we multiply that by 2 to get a side of 6 squares going vertically. So drawing my new shape here, 1, 2, 3, 4, 5, 6. Going across the bottom, there were 2 squares. Multiplying by 3 means there will now be 6. 1, 2, 3, 4, 5, 6. Going up on our L shape was 1 square. Multiplying by 3 means that we now go 3 squares up. We went 1 square back in, so we're now going to timesing by 3, go 3 squares back in. We then went 1 square up, again multiplying by 3, 3 squares up, and finally 1 square across to finish it off becomes 3 squares across. And that is our final shape. The second question asks how many times bigger is the area of the enlarged shape. Please note that this is never the same as the scale factor. When we change the length of the sides of a shape by a certain scale factor, its area will be that scale factor squared. So in other words, because our scale factor was 3, the scale factor of our area is going to be 3 squared, so a scale factor of 9. Meaning that if the original shape had an area of 3 square centimetres, 1, 2, 3, the new one has 3 times 9, 27 square centimetres. Now, in a question such as this with a diagram, if that does not make sense to you, simply count the squares. So if we count those, we've got 1, 2, 3, 1, 2, 3, 4, 5, 6. So that whole bit that I'm outlining will be 18, 3 by 6, and then 19, 20, 21, 22, 23, 24, 25, 26, 27. So an area of 27. Just remember, it is not the same as the scale factor given in the first part of the question. Okay, now we have another question where we're asked to describe the transformation taking triangle A to triangle B. Hopefully this time you can see that triangle B is bigger. That means it has to be an enlargement. So remember your options are translation, which means that it is moved, reflection, which means that it is a mirror image, rotation, which means that it has spun, or enlargement, which means that it is bigger. If you remember in the last question I said look at the marks. That is how many pieces of information I need to give. So for 3 marks I have to give 3 pieces of information. The first piece of information will simply be enlargement. So that is 1 out of the 3 marks already. The second piece of information that you should give for an enlargement is the scale factor. So look at the lengths of the sides and see what they've increased by. Looking at the top, this went from 2 squares across to 1, 2, 3, 4 squares across. So that's been multiplied by 2. Check another side, 3 squares down to 6 squares down. So our scale factor is 2 because the sides have been multiplied by 2. The final thing that you need to give for an enlargement, if there are 3 marks, is the centre of enlargement. Now, in order to do that, you need to use a ruler and accurately rule lines which go from each corner of the bigger shape to the smaller shape and on out. And then those lines will cross. Where those lines cross, that will be your centre of enlargement. Okay, so I have drawn in lines which go from the corner of the big shape through the corresponding corner of the smaller shape and out the other side from each corner. So big shape to small shape, out the other side. Big shape to small shape and out the other side. You can clearly see that these cross at a specific point. That point is your centre of enlargement. So in this case, the centre of enlargement is coordinates 1, 2. Okay, in the second part of the question, it's now asking for the single transformation which takes triangle A to triangle C. Again, thinking through your 4 options, hopefully this time you can see that triangle A has been spun around. So this is going to be a rotation. That is the first mark out of the 3. So rotation. The other things that we have to give would be the degrees with the direction and also the centre of rotation. Again, hopefully by looking you can tell that this is a quarter turn. The triangle has not turned all the way upside down. It has just gone 1/4 turn, and that would be in a clockwise direction. And hopefully that's obvious enough to see. If not, what you do is the same method that you would do to do the rotation, trace the triangle, mark where north is, and just turn your paper until you see whether it was a quarter turn or a half turn or a 3/4 turn that would match up with the new shape. So our second mark is by saying 90 degrees, and you must give a direction clockwise. The final mark is the centre of rotation. There is no easy way to do this. This is a case of trial and error using your tracing paper. So trace your shape A and then pick a random point to try as your centre of rotation and try to spin your tracing paper around that point and see if the triangle matches up. So for instance, you might start with point 0, 0. So starting with point 0, 0, I would put my pin there, I would turn my tracing page, and I would see if it matches up with the new triangle. Now let's try that and see if it works. Okay, so try 90 degrees clockwise about point 0, 0. We get there. And we can see that that doesn't match up. So we need to go back and basically try again. So 0, 0 didn't work. Let's try another point. This time, let's try point 0, 1. Okay, if you compare that to the last one, you can see that it's getting further away. So what we did there was we went higher. We went from 0, 0 to 0, 1. That was the wrong thing to do because that's now further away from C than it was originally. So let's try another point. This time we're going to try something lower. So let's try 0 minus 1. Okay, that's getting better. It's definitely closer, but we're not quite close enough. Let's try going down again and try maybe 0 minus 2 this time. Perfect. There we go. So we can see now, using 0 minus 2 as our centre of rotation, that when we go 90 degrees clockwise, the triangle fits perfectly on top of the new shape. Therefore, we finish off our question by simply writing the centre of rotation, which we found to be 0 minus 2. So we now have 3 marks. The word rotation is a mark, 90 degrees clockwise is a mark, and about 0,2 is a mark. And the very final part of this question is to draw an image of shape A under a translation of 1, 5. Remembering that the top number tells us how many squares to the right or left, and the bottom number tells us up or down. A positive 1 on the top means that we're going to go 1 square to the right. So beginning here, we go 1 to the right. Negative 5 means we then go 5 down. So my new corner is there. Repeat this with the other corners. 1 square right and then 5 down. 1 square right and then 5 down. And connect up your shape. And that will be the answer to part B. Okay, we did a previous enlargement where we were not given a centre of enlargement, and that just meant that we had to draw a bigger shape. If you are given a centre of enlargement, that means that as well as drawing a bigger shape, you're also looking at the distance between the centre of enlargement and each of the corners. So if I just label my corners to make this easier as A, B and C. The distance from the centre of enlargement, C, to corner A is 1 square across and 1 square up. Scale factor 3 means I times those distances by 3. So instead of being 1 square across and 1 square up, it now becomes 3 squares across and 3 squares up. So my new corner A is going to now be there. For B, instead of going 1 square across and 1 square down, I'm going to go 3 squares across and 3 squares down. So corner B will now be here. And then to corner C, I originally go 1, 2, 3 squares across and 1 down. Multiplying that by 3 means I'm going to go 9 squares across and 3 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So that is my new position for corner C. I then connect up my points to form my triangle. Okay, in this question we have another describe the transformation. Again, there are 3 marks up for grabs. That means you have to give 3 key pieces of information. So check through. Translation, has it simply moved position? No. Enlargement, has it changed size? No. Reflection, is it a mirror image? No. So therefore this is a rotation. You can see that it is turned. Remembering that we do this by first of all tracing our shape. And all we can do then is use trial and error to get our piece of information. How much of a turn has it been and what's the centre of rotation. Marking my north line just to help me here. So, beginning to move my shape. It's a good idea to first of all just try the origin. as your centre of rotation, and that'll help give you an idea of how much you've had to turn the shape, and then you can start to move from there your centre of rotation. So starting to turn this about the origin. A quarter turn brings me to there, which I can see because my arrow has gone from north to east. Continuing on, I can see I'm now at south, and my shape still does not look correct. Continuing to move this shape so that my arrow is now pointing west, you can see now that although the shape is not in the correct position, that it matches the rotation to shape B. The sides are pointing in the same direction. So that has been a 3/4 turn. It's gone from north to east, south to west. That's been a 3/4 turn in a clockwise direction, which could also be stated as a 1/4 turn or a 90-degree turn in an anti-clockwise direction. So marks wise, we know it's a rotation. We've got one mark. We've now worked out that it's a 90-degree anti-clockwise rotation or a 270-degree clockwise rotation. So that's your second mark. We need the centre of rotation. Now I've done that using 0, 0, so clearly that was not the right centre of rotation. So if I return my shape to its original position and now move my centre of rotation. Now that seemed to put it in completely the wrong position, so I don't think I'm very close to the right centre of rotation, but I'm not sure which direction to go in yet. So I'm going to try moving it, say maybe across to 1, 0. So I've now got 1, 0 as my centre of rotation. When I spin my shape now, my quarter turn anti-clockwise. No, I'm still not really getting very close here. I think I need to move my centre of rotation further away from my shape because I want my shape to end up a good bit further down. So again, going back to the original position, I'm going to try bringing my centre of rotation now right the way down to 1 minus 2. So I'm now at a coordinate of 1 minus 2. Spinning now this time 90 degrees anti-clockwise, you can see I'm getting a lot closer. So from the original position and going 90 degrees anti-clockwise, remember the arrow helps me know when I've got to 90 degrees because the arrow now points due west. I can see that I'm really very close, but I'm not there just yet. So I think I'm in line with where I should be vertically. I think minus 2 is the right correct y coordinate. I'm going to try now 2 minus 2, so 1 square over to the right. So I've now got 2 minus 2 as my centre of rotation. Spinning this now, yeah, there we go. Now it's not perfect, and that's just really because you can see my drawing at beginning wasn't completely perfect. So don't worry about that. When I go to the west, you can see that is fitting on top of the shape. So that is the correct answer. That was a coordinate of 2 minus 2. That was what I used. So in order to answer this question, we're going to say that this is a rotation. We're going to say that it is 90 degrees anti-clockwise, or you could say, if you wanted, 270 clockwise. So either a quarter turn back or 3/4 turn forward. And the centre of rotation that we found there was 2 minus 2. So centre, 2 minus 2. So that is 1 mark for the word rotation, 1 mark for 90 degrees anti-clockwise, and the final mark for the centre of 2 minus 2. Okay, quite nice questions now, based mainly on symmetry. as well as some enlargements. In the first one, we're told that the small rectangle has been enlarged to give the big rectangle, and what is the scale factor? Simply look at the length of the sides and see what you're multiplying by. For the small side, it's gone from 1 to 3, and for the big side, it's gone from 2 to 6. So I've times by 3. So the scale factor is 3. In the next one, we're asked to shade in one square to give the shape one line of symmetry. So for one line of symmetry, we have a couple of options. We could shade in that square, which would give a vertical line of symmetry going down the way. Alternatively, if I just get rid of those, I could also shade in this square, and that would then give a horizontal line of symmetry going through there. So those are your two options. You can either do the one that is highlighted in blue or the one that is highlighted in red. In the second part, it asks then, the third part down the bottom here, part D, it asks you to shade in 9 squares to give a shape with order of rotational symmetry 4. Order of rotational symmetry 4 means that as you spin that around, it fits on top of itself exactly 4 times. In other words, you basically want the pattern to be the same 4 times around the shape. That's what you want. Now the pattern that is there at the minute is 3 squares in sort of an L shape. So what we need to do to work out what the correct squares are to shade in is, again, we can do this using tracing paper. Trace the squares that are there, spin them using the center of the shape as a center of rotation, and that will show you each of the 4 places where they need to fall on. Okay, so as I spin the shaded squares using the center that I've marked there as my center of rotation, I can see that I need to shade those squares, and then those ones, and then those ones. So let's try doing that now. Okay, so I've now shaded in the squares, which I think are the correct ones. And again, using my tracing paper, over the top of the squares that I've done, I'm just going to spin this again about the centre to check that as I go round, it all lines up 4 times. So my first quarter brings me to there, and everything lines up. Halfway brings me to there, everything lines up. 3 quarters, and finally back to the start. So that was 1, 2, 3, 4 is back to the start. So that is 9 squares shaded in, 3 for each of the extra L shapes, and my shape now has order of rotational symmetry 4. We have another question now on describing the transformations. So first of all, we're asked to describe the transformation going from triangle A to triangle B. This is simply moved position. So this is going to be a straight translation. And although this is just one mark, we do need to give the vector here. So if we consider the top corner, we have gone 1, 2, 3, 4, 5, 6, 7, 8 squares across, and 1, 2, 3 squares down. So that is a vector of 8 minus 3. So translation of 8 minus 3. Looking at B to C, again, hopefully you can see that this is a straight reflection. Mirror line will always be halfway in between, and it's quite easy to see this time that that's the x-axis. Now remember, the horizontal line is actually the opposite letter to its axis. So you could say reflection in x-axis, or you could say here reflection in y equals 0, which would be the equation of that line. The last one is triangle D to triangle B. So again, hopefully we can see here that this is a rotation, that is spun. So we need to do that again by tracing paper. So let's have a look at how you would find the answer to part C. Okay, so using my tracing paper, I've traced around shape D, which was the original shape. It said the transformation from D to B. And I've drawn on a little north line just to help me see when I go 90 degrees, 180 degrees, and so on. It definitely looks like I'm going to want to turn in an anti-clockwise direction this time to get from shape D to shape B. And it looks to me like it's going to be a 90-degree turn in the anti-clockwise direction. As always, I'm starting with my origin at 0, 0, and I'm just going to try doing this to see how it goes. So a 90-degree anti-clockwise turn from the origin of 0, 0, stopping when my arrow is pointing due west, which is now. So you can actually see that that has perfectly lined up. So this time the origin was the perfect place to start. So quite simply, that was a rotation of 90 degrees anti-clockwise about the origin. So let's just fill that in. So we would just say rotation 90 degrees anti-clockwise about 0, 0, which was what I used as my centre of rotation. Okay, and a nice easy shape here, just a sort of compound rectangle shape, and we're asked to reflect it in the mirror line. When you're doing a reflection, look at each corner one by one, count the squares to the mirror line and straight out the other side. So starting here with this corner, that is 1 square to the mirror line, so I go 1 square out the other side. Again, this corner is 1 square to the mirror line, so I'm going 1 square out the other side. The top corners here, this one is 1, 2, 3, so I count 1, 2, 3 out the other side. Again, with this one, 1, 2, 3, 1, 2, 3 out the other side. And finally at the top, this one is 1, 2, 3, 4, so 1, 2, 3, 4. And the last one from here, 1, 2, 3, 4, 1, 2, 3, 4. I now have the outline of my shape, which I simply just need to now connect the dots. Okay, quite an easy one again. Now next we've got shade in 1 square so that the shaded shape has exactly 1 line of symmetry. Now again, we have 2 options. It could be a vertical line of symmetry, or it could be a horizontal line of symmetry. To put in a horizontal line of symmetry, I would need to shade that square. Alternatively, if I wanted to do a vertical line of symmetry, I shade that square at the bottom. A diagonal line of symmetry is not going to work in this case. In part B, it asks us to shade in 1 square so that the shaded shape has rotational symmetry of order 2. Now that's a little bit trickier for this one, and there is only one correct answer. I would recommend that you do this with tracing paper again. So tracing around the outside of my shape. Okay, and I'm now going to spin this to see where the square that is the issue, which we can clearly see is this one. The h will happily fit on top of itself, that isn't a problem. This is our extra square, and this is the one that we have to basically even out by adding in one more square. So we need to see, when we turn this, where does this square add up? Okay, so starting to now spin this shape, we only want it to fit on itself in one extra place as well as its original position. And we can see that this is where that should be, so you can clearly see here where your extra square needs to go. So shading that in, that would be our extra square. In the final part of this question, what is the scale factor of enlargement from shape A to shape B? Again, just look at the sides. 2 squares to 4 squares, 3 squares to 6 squares. You're clearly multiplying by 2. Another complete the picture for a symmetry question. These are quite popular, especially on the T5 paper at GCSE level. I do recommend taking the time to use tracing paper with these, because these can be done quite badly by people trying to do this by eye. And in fact, I know that this particular question was very poorly done, whereas the simple act of using tracing paper will mean that you will get these right every single time. So trace your existing shapes. Now, if we want rotational symmetry 4, we can clearly see that we want to replicate these shapes in our remaining 2 quadrants. We just need to know exactly where they go. Now I have traced here, and I'm going to use my origin here as my centre of rotation. And when I now spin these shapes, I can see where I need these to end up for my shape to have rotational symmetry of order 4. So you simply would lift your tracing paper and shade the shapes in the appropriate position. The most common mistake by not using tracing paper is people having their sort of arrows pointing the wrong way. So that will really help you if you take the time to do it properly. Okay. Moving on to the next slide. Again, another simple reflection. And again, just take your time with this. Count your squares from each corner and out the other side. I'll zoom in slightly here to make this a little bit easier to do. So from this corner, it's 1 square to the mirror line, 1 square out the other side. This corner, 1 square to the mirror line, and 1 square out the other side. That corner is 2 squares to the mirror line, so 2 squares out the other side. This one is 3 to the mirror line, so we're going 3 out the other side. The same with the next one, 3 down. And this one is 1, 2, so 1, 2 to there. The one beside it, and then going further out again, 3 squares for the remaining ones. Again, we simply now connect up the dots to make our shape. A good tip when you get into doing these on a GCSE paper is to shade them in to make the shape a little bit easier to see, because your paper will be scanned into a computer. So sometimes the lines are not thick enough and it's a little bit hard to see, so always shade your shapes in. Okay, a line of symmetry on the shape below, hopefully easy enough to see. You're just looking for a nice diagonal line there going through the corners. Name the 4-sided shape which has rotational symmetry of order 4. That should be one just simple recall that you know off by heart. That is a square.